you can call me if I don't offend anyone. I'm not from China, but yes, I am a giant panda. So I need some cool. Okay, I don't usually wear my jackets in Delhi till it's 8 or 9 degrees centigrade. Till that time, I don't wear my jackets. In this entire winter that just passed, not a single day did I wear a sweater in my class. Not a single day. So that kind of uh, polar wear. That's why polar wear. Okay. In the winters also, when I will walk, I would sweat, but then I realized I had a lot of fat. So that's the reason. Okay. So I'm very sorry, but I'll need some air conditioning after some time. So if you guys have some problem, please shift. Okay. Yeah. So how are you guys doing? All good? Had some flavor of Holi yesterday, or no zeal of Holi at all? Nothing. Okay. There were few students who were playing Holi here. I mean, at the that lane. So it was like, okay, maybe my students are also playing Holi. No issues. It's a very different kind of experience that I had yesterday. All my colleagues, all my friends, everyone was free. I was the only one who went back home at 5. I was the only one. And everyone was literally angry on me. Don't you remember it's Holi today? You don't have this kind of etiquette that you should be wishing me. And then I told them, dude, I had class. And then they were like, okay, we get it. Right now our US clients are sleeping, that is why we are also here. In the night we also have to work. Well, good enough. What can you do about it? Even they are not free. Yeah, come. Okay. So ready for today's class? Today we dive into some more scientific principles. Okay. And we'll see how, the things go. How exactly can we optimize our concept building? Because from now and henceforth, you start building your concepts. Okay. Because what are the things that are going to come in this particular session have been asked in UPSC in some manner or the other, and how exactly they have been asked will be shown to you via PYQ. Okay, so that is why we need to now focus all our attention here. All of you have got your visiting card that I gave you on the first day. Do you still carry it? Have you placed the other one at a high priority zone at your place? Do you see it every day? Do that. Do that till the day it is printed for you. It's very important. Okay, don't do it the other way around, that you forget it. If you want motivation, you are the only person who can motivate yourself for doing anything. Nobody else is going to be motivating you, because every one of us has something called a matter of choice. The day you choose that I have to march ahead, you will march ahead. The day you choose I'll take some comfort in whatever situations I have, you will do that. Things will not change. So that is why I gave you on the very first day the pill for motivation, and that is your soul motivation. Okay, eventually you will be understanding the why aspect of it. Why do you want to be a civil servant? Okay, whatever post you wrote down, why, that will come to you after you study. Okay, but till then, that single piece of paper is the only objective that you have. So become snipers. Okay, you don't have to miss. Become snipers. One target. Okay, chalo. So let's begin today with gravitation. Okay, anyone who has any idea about gravitation? I'll come to these two at the last, and her also. These are because these are from science background. All the others, he is the last one to be grilled, don't worry. He just has done one mistake in his life. He's a mechanical engineer. That's his sole mistake. He's a very nice fellow otherwise. Yeah. What do you understand by gravity? Okay. What exactly is a fundamental force? What do you understand by a fundamental force? Yes. So these are inherent in the nature. See, one of the biggest irony with any force is we don't know its origin. There is no force for which we have a definite origin? We cannot say that. Gravity, we don't know the origin. Nuclear force, we don't know the origin. Electrical charge, no origin. We don't know how a particular atom gets ionized. Yes, we do understand that an atom gets ionized because of the ionizing radiations, because when you accept energy, you ionize. We understand that. But what prompts it intrinsically? We don't know that. Okay. So the entire physics is based on one very significant assumption, that there is force. There is force. But if I ask you what is the origin of the force, it is a very difficult question to answer. Have you read something about it? In your college, have you read what exactly is the origin of a force? You only read about the nature of the force, types of the forces. That's it. None of us can answer that question. From where does that originate? Okay, yeah. Fundamental force. Then, what do you know more about it? It's one of the four fundamental forces. Then, yeah. No, gravity. You tell me about gravity. Fundamental forces we'll discuss. Okay. 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 So that is how you characterize gravity. Nice. Anyone else who has any other insight to give me? Now I'm looking at the engineers here and the physicists. Any other thing that you would want to add upon? Good. That is the single most important aspect we have to talk about. Next. Anything else that interesting? Nothing interesting, guys. What exactly is this? You don't know anything additional to this? What kind of resistive force? Okay, so now he's talking about the experiment that Galileo did from the Leaning Tower of Pisa. Okay, then good one, by the way. Good observation. In the absence of any resistance of the force, resisting force, the things are going to fall down at the same time. Yeah. Next, you're about to say something. You would like to add something? See, guys, I'm not challenging you with your degrees, but yes, every one of us here has got some edge over the other. Use that edge. Okay, these guys come from commerce background. They will have their edge in economy, and I will have no qualms if they basically say that we are going to excel in economy. When we are writing economy answers, we are going to give something more that the other people are not going to give. Well and good. So please wake up the engineer inside you, wake up the science person inside you. Okay, and get a little bit extra. I'm not saying that you have to go completely technical on this and you come up with a differential equation that is to be solved. No, but yes, use your background, use certain things that are rarely said or which are not known. Okay, just like I told you, forces, we do not know their origin. This is something that we all understand. We all work on an assumption. The entire engineering fraternity works on this assumption, but no one says it out loud. If anyone says it out loud, that is where it becomes interesting. Okay, this is something which we did not know, and that is what distinguishes your answer. Do you understand it? So that little amount of value addition comes from your background, and only two ways that you can be adding some amount of value to an answer. Either you are reading a particular subject as your optional, there you would, from there you could be quoting something that would be an additional or a layer about this, or your educational background. So use it. Don't just keep it with you. Use it. Just like that guy can excel answer when he talks about cyber security. Whenever there would be a question on artificial intelligence, okay, he could write a lot about it because he's doing a degree in that. Don't waste that. You have actually invested 4 years of yours in AI and ML. Okay, nobody in the UPSC field knows it better than you in the aspirants. So don't just take it for granted, use it. Okay, so is the case with you. You can be writing very nice essays because you have a creative hand. You can be writing very nice essays. Okay, essay, ethics paper, these are the ones which attract marks. Optional, these are the ones which are actually going to make or break your attempt. Okay, so there use your creativity, use that extra edge that you have over others. That is what is going to be the rank differentiator. Okay, so coming back to gravitation. Gravitation, as you have already said, that gravitation is a force. It's a fundamental force. Fundamental force basically means that this is one of the forces which have been there since the very beginning. We do not have to undertake a separate process to get this force generated. Okay, just like when you talk about tension. Okay, imagine you understand tug of war, that game tug of war. So unless there are two teams which are pulling this tug of war, the rope is not going to get taut. Okay, if the rope is lying like that, it will not be under tension. But once it starts getting pulled on both the sides, it starts getting taut, right? So when it starts getting taut, what exactly is the reason? Because someone is pulling it. Okay, if you lose it again, it will again go back to the same state. Okay, but with respect to gravity, even if you don't do anything, this force will still act. With respect to any of the atom, it does not usually spontaneously disintegrate unless some amount of instability is added to it. Okay, that instability is some kind of external energy. You are heating that thing up, you could be shining some energetic light on it. Okay, so some kind of electromagnetic radiation which increases its internal energy. So unless the internal energy is increased, things usually do not spontaneously scatter. Just like, let us say that you basically are in a competition, and this competition is about how many bottles of water can you take up before you throw up. Everyone will have a different capacity. But what eventually is going to happen once you are taking in water, when you are sipping in water, so after a point of time, you start feeling your entire gut, your entire torso is going to be filled. You will feel like that. Okay, that now it is the time that if any little disturbance is made, I give you a jostle, I give you a light push, you might throw up. So what exactly has happened? You first of all have absorbed that amount of water with you. Okay, and that amount of water is not getting digested right now, because your body does need water, but it does not need so much water at the same time. So what will happen? You will throw up. Okay, so that is basically how most of the things in the nature disintegrate. So first of all, you will have to absorb some energy from some source. That could be heat energy, that could be coming from light, that could be hammering. Okay, once that happens, once you have absorbed that energy, you start disintegrating. Till then, you don't disintegrate. You don't see the walls disintegrating, God forbid they do not. Okay, but still, why? Because all of these atoms have something intrinsic in them that is called as a nuclear force. That nuclear force binds all the things inside the atom together. Okay, so this is again a fundamental force. You do not have to come up with a additional process to generate this force. Do you understand this? Okay, you have seen a cooker, pressure cooker, boiling something in the pressure cooker. So in order to boil something in the pressure cooker, you'll have to give heat. You'll have to close it from the top, and you'll have to use the whistle, that weight bob which is there at the top. Okay, once you have this entire assembly ready, and then you put it on flame, it starts absorbing the energy, the heat energy, and because of this heat energy, whatever content is inside, that will also have some amount of energy, because you are going to pour in some water. I hope you understand this much. Okay, that you pour in some amount of water, that water will turn into steam. Why? Because of the walls of the pressure cooker. Once that water turns into steam, and it turns into steam in such a manner that the vessel is smaller than the volume of vapor, the whistle is going to go off. That is the whole point for that whistle to go off. If it does not happen, your cooker will explode. Okay, it will explode if that whistle does not go off. It means that the cooker is not able to handle that amount of vapor, and eventually it will explode. Understood? So this should tell you that in order to get that steam, you had to provide heat. Okay, and once that steam is something which is pressurized to a very large extent, only then it will explode, or only then it will displace the vessel. So this is a force which is generated due to heat. Okay, so this is the difference between fundamental and other forces. Do you understand this? So gravity is one such fundamental force. You do something or you don't do something, it doesn't matter, it will always act upon your body. Okay, with respect to gravitation, what do we have? How do we feel it? We feel it in terms of our weight. Okay, every one of you have got some weight. You stand on a weighing scale, unless you are me, and then you take your weight. Okay, so the reading that you actually get is your weight. Now that weight basically means that whatever is the matter content inside your body, okay, how strongly does the earth pull that mass towards itself? Okay, now these are two different things. Weight is a force, mass is what is there inside your body. Okay, all of us have a different proportion of mass. Okay, and that is why when we stand on the weighing scale, we have different weights. So the force with which your mass is pulled by the earth reflects your weight. Okay, that is why in physics, when you read this thing in physics, you characterize this as mass times gravitation, or mass times acceleration due to gravity. This annoying formula is something that all of us have read, at least till class 10th. Okay, and yes, some of the lesser fortunates, we have read this till date. Okay, all these engineers, physicists, we do it like that. Okay, what does this mean? It is your mass which is going to be pulled using something called acceleration due to gravity. So that is why we say weight is a force. Now acceleration due to gravity basically means that if I have a particular thing and I drop it, if I drop it, it automatically goes down. So what we do is that we know what is the weight of this object, we calculate the time it takes to drop down or crash down. We calculated the time, we have the weight, and then subsequently what we do is that we measure the height from which we actually dropped this. Okay, so from the height that I drop this, let us say this is about 120 meters, 120 centimeters, I drop it. So from that height, what is the time taken for it to reach the ground? This will give me velocity. From velocity, I can come to my acceleration. So acceleration is basically what you see as the force behind, you can say the reason behind any force. Okay, so force basically is characterized as mass times acceleration. How quickly a mass is moved is something which is going to be called as force. Okay, so just like imagine that you basically are pushing a box full of books. Okay, so when you're pushing that thing, initially it is a little difficult for you to push, but then you start pushing it. Okay, you apply some more force. The greater the force you apply, the faster it is going to move. So the faster it is going to move is characterized by acceleration. Okay, so higher the acceleration, greater would be the force. So that is why you would see that when you can say when you are actually, when some of your small siblings, or if you have any nephew, niece, anyone at your place, if they come running towards you and they accidentally hit you, it hurts. Okay, why? Because they are coming at some velocity towards you, they are running towards you. Or if you do not have that, if you have a pet, you might get hurt because the pet might have the same amount of mass as you. Okay, so why does this happen? This happens because the other body is coming towards you with some amount of speed. That speed is characterized by two things: how fast you are moving, that is given by acceleration, and from what distance are you moving. Okay, so that is why, are you aware that the T20 World Cup is going on? How many of you watch cricket? I expected that. Ladies, no one? You know World Cup cricket is going on? Today's India-England semi-final, you know that? Have you ever seen a cricket match? Even in your childhood days? India Pakistan, maybe Shoaib Akhtar, Sachin Tendulkar kind of rivalry, I don't mind. What happens is that you would see that when you have a bowler who bowls, okay, he comes running from a distance, and after running from a distance, he or she basically bowls. Okay, if the distance is longer, they are basically going to throw a faster ball. Okay, if the distance is shorter, they are going to throw a smaller, you can say a slower ball. Okay, so what does this tell you? That you basically are trying to gather that amount of momentum inside you before you throw that ball. Okay, so that is something which is actually called as force. Okay, so with respect to weight, weight is a force where this acceleration is replaced by acceleration due to gravity. Okay, we just replaced this. We have found out a value for this, that it is basically 9.81 meter per second square. That's it. Okay, and we just multiply it with the mass. We get the weight of an object. Okay, why do we need this? We need this to understand what would be the amount of force that will be required to at least lift you up from the ground. How many of you have traveled in airplanes? None of you? Seen airplanes in the movies or at least somewhere? Airplanes are huge. Okay, they are huge. Just imagine that such a huge object, if it has to fly off, it is not flying off like just like that. It has passengers, it has got luggage, it has got fuel, everything, but still it flies off. So when it is flying off, it takes a long run. That is why it is called as a runway. It starts from one end, it keeps on gathering some amount of speed, continuously some amount of speed is gathered, and after some time eventually it lifts off. Okay, it happens eventually. If it is not to happen, imagine a rocket. Okay, so in a rocket you deliberately conduct explosions and violent explosions so that it lifts off the ground. Okay, so in order to understand what would be the amount of energy, what would be the amount of force that is required to lift anything off the ground, that is something which is calculated using the weight. So it basically means that, let us say your weight, anyone would like to disclose their weight? I'll not, because I'll let you guess. Yeah, yes please. 52. So if there is a rope, okay, if there is a rope which can manage the weight of madam, okay, and if she holds on to that rope is pulled by someone else, she will be lifted off the ground. At least she will be lifted off the ground. Why? Because right now anyone who's exerting a force which is greater than her weight, it will pull her up. That is the requirement of gravity. That is something which you calculate so that you understand what is the force that is required to lift something up. Okay, so when we launch satellites, it becomes even more important. When we launch, if you have to launch a satellite, what happens is that you have to completely escape this gravity. If you are in this gravity, you will crash down. So that is why when we have to do that, we have something called as escape velocity. Escape velocity is basically that amount of speed that an object should has, so that when it is projected into the sky, when you throw it into the sky, it will continuously keep on going outside the earth. It will not come back. Okay, that is something which is the utility of weight. And why exactly is this done? So that we understand gravity. So gravity is the force with which any object attracts any other object right to its center. Okay, so gravity, the ultimate destination of the force is basically to the center. So every object, everything basically is going to be pulled towards the center. Now the point being that gravitation is something that is exerted by every physical object. Doesn't matter its size. You are also exerting a gravity. But gravitation becomes important when you have very huge amount of mass. Okay, when you have very high mass, it becomes significant. Now with respect to the earth, we have very less mass. So when we have very less mass, earth does have a force of influence from all of us, but because it is so massive, it does not move towards us, rather we move towards it. Okay, so one thing that you should understand is that when someone is strong enough to pull you towards themselves, only then you will be able to move. Okay, now let us say that when you are walking back to your home, there is a puddle that comes in the middle. Okay, and you were actually busy doing something on your phone, or let us say you were walking and you did not know it. So what happens is that as you step accidentally on the puddle, you are actually going to go down. It will not be the case that you will stay there like a statue. You will go down. Why? Because gravity is still acting on you. It is still pulling you closer to itself. Okay, and the other way around, you cannot expect that that puddle is going to come towards you. It will become very injurious. Okay, so what does this tell you? That gravity is something which will pull everything towards itself. Okay, but when the mass is really high, it is something which becomes very important. So this gravity was something which was discovered accidentally by Newton. Now this is something which we already experienced, but we never characterized. So one day Newton was actually sitting in Trinity College in Cambridge, London, and he basically was sitting beneath an apple tree. It is supposedly said or allegedly said that he was actually coming up with a new scheme to con his clients. I told you yesterday that there is a rumor that Newton actually was a con man. You understand a con man? Someone who dupes you. Okay, so what basically, or a hustler if you want to call it. So it is believed that he was actually coming up with a new scheme to hustle his clients. And then subsequently what happened was that an apple fell on his head. Okay, and that accident actually made him realize that, okay, why did it fall down? Why exactly did it happen? And then subsequently he characterized gravity. Okay, and he named it as gravity, that everything is going to be attracted towards the earth. Even if you jump, you will be attracted towards the earth. Okay, even if you you can say hop, you will be attracted towards the earth. Now comes the question, why does not this happen with the birds? Birds also feel that gravity. The only reason they are able to fly is because they continuously move their wings. Unless they do that, they will also fall down. You might have seen this during the time of summers, when the birds get very thirsty, they actually fall on the ground from the tree. Wherever they are perched upon, they will fall down. Why does that happen? Can't they fly? They don't have the energy to fly. Okay, that's the thing. Okay, so he basically gave a very unique law to the world, that is basically known as Newton's law for gravitation. Okay, so that is known as Newton's law of gravitation, or you can call it the universal law of gravitation. With respect to this particular law, he said every object in this universe attracts every other object. Okay, every object in this universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of distance between the two. Basically it means that it basically has two parts. Okay, there is a force which is directly proportional to the product of the masses, whatever is the product of the two bodies, the product of their masses, and it is inversely proportional. So inverse proportion is basically written as 1 divided by, okay, the distance between the two. Okay, so that is written as r square. Okay, r is basically what we use as a notation for the distance. Okay, so combining these two, we basically have this particular force as m1 m2 by r square. Okay, so this is basically how you can characterize the force of gravitation between any two objects. Okay, so the greater the amount of mass, the greater would be the gravitation. Okay, greater the amount of distance between the two objects, lesser would be the gravitation. Do you understand inverse proportion and direct proportion? Okay, so what is directly proportional? The mass of the two objects. Higher the mass, higher the gravity. Greater the distance, lesser the gravity. Okay, So now this is a particular equation that could be used in any two body system. Two body system basically means that you are considering any two objects out of the many. Okay, just like let us imagine you and him. Okay, now the center to center distance between the two of you, okay, and the product of your masses, we are going to calculate that what exactly is going to be the force in between the two of you. Now what happens is that this force for smaller masses becomes exceedingly small. It becomes exceedingly small. Okay, when we remove this particular proportionality sign, so we have to actually add a constant, and that is called as capital G. Okay, m1 m2 upon r square. Okay, now this proportionality constant basically is 6.67 into 10 to the power minus 11. Okay, so that is basically the value of this G. Now just imagine your weight, I guess, would be somewhere around 70. Your weight is somewhere around 72, 70. So just imagine 70 into 70 divided by, let us say that distance is about 1.5 meters. Okay, so 1.5 meters squared. This value will be very low. 70 into 70, 4900. Okay, 4900 divided by 1.5 square, that is 2.25. Calculate it. Calculate it if anyone has a calculator, and those engineers who have their scientific calculators. You have a scientific calculator? Okay, then calculate it using the normal calculator. Divide 4900 by 2.25. 2177. So it goes on 777. Okay, yeah, and now multiply it with this 6.67. 14,525.777 into 10 to the power minus 11. Now divide this entire thing by 1 followed by 11 zeros. Don't do that. Don't torture yourself with that. Just tell me if this number is going to be divided by 1 followed by 11 zeros, will there be any significant force? Will you get any force? It will be literally 0. If you want to calculate 1, 2, 3, 4, 5, okay, these are 5 numbers before the decimal points, and if I divide it by 1 followed by 11 zeros, so even before this you will be having 6 more zeros. So 0.00000014525, that is the force between you two. That is why you both are sitting at your positions, and that is why all of you are sitting at your position. That is why I said if the mass is great, your gravitation would be great. That is why we don't feel, I mean, that sometimes when you are walking on the street you get slammed into someone else. That is the amount of force that acts between two objects which are very small. With respect to the mass of Earth, we are very small people. So that's the reason. Okay, so I hope that part is also clear. But this is something which is important. This becomes very important for a lot of different applications. Okay, when we will be studying about black holes, this becomes very important. When we are actually launching satellites, this is of prime importance. Why? Because when we talk about satellites, satellites have one thing: they have to continuously orbit around the Earth. Let us say, you know, International Space Station, Hubble Space Telescope, Aditya L1, Chandrayaan, Mangalyaan, anything. These all have just one thing: they have to revolve. What do you know? Chandrayaan? Everyone knows Chandrayaan? Okay, so when you talk about Chandrayaan, Chandrayaan is basically a space satellite that has been made by ISRO for the moon. Its job is to take revolutions of the moon and continuously take pictures. Okay, so when it is to revolve continuously around the moon, it needs to be in that particular orbit always. It cannot crash into the moon, it cannot go farther from the moon. Whatever is the destined point, you have to be there. Okay, and in order to keep you there, we will have to stabilize this force, because the moon also has some amount of gravity. If you remember Chandrayaan 2, when it was descending onto the surface of the moon, it crashed at the end. Why? Because that gravity could not be managed. They could not slow down the probe which was carrying Pragyan, and subsequently it crash landed on moon on the farther side. Okay, so what happens is that this calculation becomes very important for us to understand at what distance from the earth should we place a satellite, first thing. Second, when the satellite is going to revolve around or orbit around the earth or moon, at what speed should it do it? This is something which we understand from here. Okay, and that makes us decide what orbit, which satellite, and what speed. Just like when you talk about International Space Station, now it orbits the entire earth. You can say it travels the entire earth every 90 minutes. Can you imagine? 90 minutes you are across the entire world. That is the speed at which ISS is traveling. Okay, so it's about 800 kilometers per hour. 800 kilometers per hour. That is greater than what is actually the speed of most of the commercial airplanes. So that's the thing. Okay, the closer you get, the faster you will have to rotate. The farther you are, the slower you rotate. Why? Because gravity is going to be lesser and lesser as you move away. But as you come closer, it becomes very, very strong. Okay. Do you know that recently in the Dubai Air Show, we had one of the Tejas aircrafts crashed? Okay. It crashed because eventually when it was coming down from the maneuver, it lost control because the gravity overpowered it, and its engine could not produce sufficient power so that it can go up again. So when that happens, gravity pulled it down and it crashed. Okay, so that is the whole point. If you are flying, even if it is a bird, for that matter it is an aircraft, it needs to have a continuously operating engine so that it can produce sufficient amount of force to keep you afloat. If it does not, it will crash. That happened with Ahmedabad crash, that happened with Tejas. The same thing. Okay, understood what is gravitation? Okay, now gravitation is something which pulls things towards itself, and that is why we see natural satellites revolving around the planets. It is basically the interaction of gravity. Now it means that this object Earth is exerting a gravitational pull on the moon, but at the same time the moon is also exerting a gravitational pull towards Earth. But because the Earth is more massive, it has a stronger gravitational pull. That is why you have a bold yellow arrow to indicate that the force of gravity by the Earth is greater, and you have a smaller reddish arrow that tells you the gravity of the moon for the Earth. It is smaller. So that is why wherever these two balance, the gravitational pull of moon over the Earth and gravitational pull of Earth over the moon, wherever they balance, that is the point where the moon revolves. Okay, it is the balance of the tug of war. If both of the teams have got equally strong candidates, the rope is not going to move in either direction. But if I come and dislodge anyone by goring them, then definitely the other team is going to win. Yeah, why? Because that force has been disturbed, and it will then subsequently move in the direction which is stronger, which has got greater force. So your movement in any case inside geography will happen in that direction where you see that the force is strong. In whatever direction, if it is strong in the vertical direction, things are going to come down. This is how landslides happen. If the force is strong in horizontal direction, things are going to go in the horizontal direction. That is how air moves. Okay, what are the reasons? We are going to decode place by place, but this is how you see the difference. Anytime the equilibrium is disturbed, there will be a movement, and this movement will be in the direction in which the disturbance has been carried out. Do you understand this? If you understand this, you have done your 11th class physics. This is exactly what you are expected to calculate. in the mechanics portion. Okay, but alas we did not do it there. Now talking about stars. Okay, so when we talk about stars, this is where the real physics begins. Stars we have characterized yesterday as massive objects, okay, made out of gas, have their own source of heat and light. This is what we have characterized it. And yesterday I told you that we are going to read about the source of the energy, that is known as nuclear fusion. What do you understand by this word fusion? Yes, combining, that is the literal meaning. Okay, I don't want a technical meaning. So fusion basically means that you combine two different things. You might have heard about fusion dosas, if you don't get offended. There are a lot of fusion dosas in Delhi, and every single one is going to piss you off. Okay, but we can't do anything about it. We don't get dosas like here. Okay, you have a lot of fusion where today fashion is also some kind of fusion, something called as Indo-Western or something like that. Do you understand this? There are a lot of different types of hybridization that happens. Okay, so fusion basically means combination of two different things together. So when two things are going to combine together in terms of physics, okay, so the combination of two things will always produce a heavier element. Okay, just imagine that you are carrying one book in your bag. I don't really expect you to carry any book, but let us say that you're carrying one book in your bag. Okay, you went back with another book. So what is going to happen? Effectively, you are going to feel, oh, I studied too much today because I have another book in my bag. Okay, let us add another book to your bag. It will feel even heavier. Now it will be too much. Okay, so what does this mean? That when things combine together, they start becoming heavy. Okay, now when we talk about stars, so stars are something which are born in clouds of gases which are known as nebula. Okay, and stars basically have almost a similar life cycle as that, like us humans. So let us first of all decode what do we do as humans, then we are going to apply the same principle to the stars. Okay, so we are all born out of womb of our mothers. They had to exert enormous amount of back breaking and bone breaking forces in order to push us out. Okay, we start from there. So we basically were also surrounded by something called as amniotic fluid in our mother's wombs. Okay, so till the time we were inside their wombs, we were surrounded by this particular fluid, and we also were receiving some amount of nutrition through our umbilical cord connected to our mom's stomach. So we are literal parasites. And not parasites, not in the negative sense, but yes, we have derived our nutrition from our moms. Okay, now what happens is that during childbirth there is an enormous amount of contraction that happens in the womb, and because of those contractions and relaxations, eventually the muscles actually start making the baby push out. With respect to our body, the only way that we can exert force is because of the rhythmic contraction and expansion of our muscles. To talk about our heart is nothing more than a pump, but that pump is something which has a definite amount of rhythm. When do we have to expand, when do we have to contract, and subsequently it pumps out the blood because of that rhythmic contraction expansion. You talk about passing stool, passing urine, is basically contraction of muscles and relaxation of muscles. That is how, if from one portion to the other, some pipe, some conduit is going to expand, and from the other side it is going to compress. Okay, so it is just like that. But with respect to childbirth, because a fully developed human is going to come out, the forces are very, very large. Okay, so what eventually happens is that the baby also experiences that compression. Okay, because that particular body is to be pushed out, and eventually you get pushed out. Okay, once you get pushed out, people celebrate, everyone rejoices. Usually in the past things were a little more hypocritical, so I'm not sure, but still the point being that when the baby is born, after the baby is born, the real battle begins for every single person. Okay, now what is the battle? From the very beginning, not all of us like milk. How many of you don't like milk? You own a cafe, madam. Please don't say that to your clients, you don't like milk. You have 100 different types of teas. Please. So what type of teas are we expecting? Boba teas? Okay. I haven't tried one yet, so I'm not very sure of it. Okay, we'll come, don't worry, we'll come to your place. We'll try tea. The coffee, is it only black coffee? Okay. Okay, so I'll get a proper cappuccino, right? हाँ ठीक है. Then it's fine. It would literally hurt me if it did not get milk. Okay, not all of us liked milk. Not all of us liked math and science. Some of us did not like history. Most of us did not like civics, right? But still we were forced to read this, at least in the school level. And every single year the same thing. Read it night this year and your life would be settled. How many of you have been given that trick? Just this year you have to work really hard. From then onwards your life is settled. I don't know what this life is settled conundrum is. What is the definition of this word settled? I never found that settlement. Right? This happened in class 10th. Regardless of what you felt about a subject, but still, no, life will be settled. You read. Every single class, you had just one pressure: don't fail. If you were a good student, don't come second. Okay? And if you are a student who was in transition like me, that you are good with studies and you are also good with sports, don't play. How many of you? That's exactly the case. I can understand your pain. Don't play, your studies will be hampered. But they never realized because of playing our studies were good. Right? So these were the pressures that we have grown up with. Okay? So till the time we reached our class 12th, we had some amount of fear in our mind for discipline. Right? Then comes college life. Even more pressure. College is a whole different fashion league. Okay, first of all, clothes. Second, your looks. Third, your company. Fourth, your relationship. Too much pressure. And then also hiding that relationship from your family. Not all of us are bold enough to accept that in front of our family, right? Too much pressure. Then sometimes the relationship also says, what next? Even more pressure. Okay? Then comes this life. Post-college. Post-traumatic life. So, sorry, the recent traumatic life. Okay, which will be the longest part of our life, where again we will be having to meet so many expectations. You are now red. Go find a job. Don't come back with a 10,000 rupees job. Come back with a 50 lakh rupees job. Come back with a 2 crore rupees job. Okay, tomorrow buy me a Lamborghini. Okay, marry Miss India. Marry Miss Universe. Marry Mr. Universe. Things like those. And after marriage, another game. Now raise a family. Take care of the family. Where is you? Nowhere. Nowhere before your retirement plan is you. And by the time you reach your retirement, you have no you. Whatever I have is for them. I earned it for them. Your parents, your grandparents say the same thing. Very rarely do you find your grandparents or parents taking a call for themselves, buying them new clothes. Gadgets they would want better than you, definitely. Now that's a new competition. My parents have better phones than me. I still use a broken phone. They have big phones. Okay, but the point being that they still would want you that whatever I've done it for you. That is why I've toiled hard. That is what we have said. But literally, have you done that for ourselves? No. You have done that only to keep yourself up in the society. And that is exactly what you're feeling right now. Go secure a job. Right? Go secure a government job. Go secure a class 1 job. Go work for Morgan Stanley like company. Right? Why? It's not for you, it's for the society. Okay, it's very difficult for her every single day that she has to go up and she has to run her own cafe. Unless it is her passion, she would always be doubted upon this. Okay, unless she becomes a real hotelier or she is someone who actually earns more than her peers, she will always be judged. What kind of step have you taken being an engineer? Am I wrong? Yeah, we face that all the time, but still we endure. Every single day we endure. Okay, we rise up, we make our day, we do something that we want to do. We definitely want to find some meaning for life, but we do something, and that is how life goes on, right? So in the life, can you actually say there was a time when there was no pressure? Can you say a single day in your life that there was no pressure? Since the time you have actually attained some amount of maturity of the world, that you have understood things, is there any single day? What exactly you have been doing till now? Resisting that pressure, living up to expectations, working extremely hard so that you are never scolded, right? That is what you have done. Exactly the same thing is done with the stars. The only difference, it does not have any emotions and no emotional pressure is there with it. The only pressure that it has is gravity. Now gravity is one such force that is going to pull you towards its center. So what happens is that gravity actually wants the star to compress completely. But what happens is that when you apply too much pressure, we start getting angry, right? And someday we explode. When we explode, whatever discussion is being pressurized on us, it stops for some days. Have you seen that? This is exactly what star does. That is what is nuclear fusion. Exploding every single moment. Because when you explode every single moment, nobody is going to dare cross your boundary. They're not trying to turn you into rebels, but this is exactly what happens. Physics and human psychology is no different. It is just a perspective we don't understand. Okay? Does this happen or not? When you get angry, when you get pissed off, the other person shuts down or you leave, but you don't want that line to be breached, right? This happens. The girls are not nodding head. I don't really know they have any concurrence with this or not, but it does happen with boys, and with me it is a very normal thing. I don't let anyone cross that line. Doesn't matter who it is. No designations. Okay, why? Because I know I am a star. No, I teach you, so I am a star. I understand physics. Physics is my friend. You are not my friend. So that is why every action has an equal and opposite reaction. You give me an action, I will react. But how will I react? That is for you to figure out. And that is how I play people. They expect that, okay, now he'll retaliate. Now he'll retaliate. I don't retaliate. I retaliate when they don't expect it. Though they don't even know I retaliated. But yes, they do get that lesson, that what exactly is the damage done. Okay. So that is how I play the game of chess in my life. But the point being that when we talk about stars, it is born out of nebula. Okay. So what happens is that from the nebula, there is an extremely high amount of gravitational force which comes into picture. Okay. How does this gravitational force start? This gravitational force starts from the dust particles which are formed in the nebula. So when you talk about nebula, you have three things: dust particles, you have gas molecules, and then subsequently you have dark energy and dark matter. Okay. Now dark matter, as I told you yesterday about dark energy, is something that we are not able to see. And because we are not able to see this matter, we are not able to characterize what it is made of. What we can see or what we can experience are its impacts. What is the impact? Because of this dark matter, there is an enormous amount of attraction that happens. Enormous amount of attraction is there in the nebula, and subsequently the dust particles, they start coming together. The gas molecules get started. They start, you can say, trapping inside these dust molecules. Okay. So gradually what happens? They start coming together as a sphere. Now nature has this particular shape, sphere or ball like shape, as its natural shape, because any force that is there in the nature works in all the directions, 360. So when it is working in all the directions, it is going to exert its influence in all the directions. So just imagine if my body is like the center of dark matter and it is to attract everything. So when it is attracting everything, eventually my entire deposition over me would be like a sphere, a spherical ball. That is what happens here. Now what happens is that when these gas molecules, these dust molecules, they start coming together, up to a certain point they are very comfortably coming together. But after that, what happens when when the things start coming too much together, very close to each other, at that particular moment of time, there comes in some amount of resistance, that is called as repulsion. Okay, the things start repelling each other. So now what is happening? One force is attractive, the other force is repelling. So because of this, what happens is that there is some amount of strain, there is some amount of tension that is there in that particular body. Okay, and this is something which starts generating enormous amount of heat. And gradually, because the gravity is something which is more, because the mass is continuously accumulating, what happens is that it starts making things come together again. So when the things are coming together again, so what happens is that these molecules, these gas atoms, these are actually the one which start combining together. When they start combining together, that is something which is known as an exothermic reaction. Okay, that is something which is known as an exothermic reaction. So an exothermic reaction is a reaction which will produce heat. Okay, it produces heat. So what happens in this particular case, when these molecules, or you can say these atoms, start combining together, they produce very high amount of heat, and this heat along with itself produces light. Okay, now that is something which is known as nuclear fusion. So here in this particular picture, what you're seeing is that these are two you can say atoms of hydrogen. Okay, one is called deuterium, another is called tritium. Now these are basically two isotopes of hydrogen. Isotopes basically mean the element is same, but the number of you can say the atomic number is different for them. Okay, there is slight difference in the atomic mass. Here you can say only one blue ball, here there are two blue balls. That's the difference. Okay, now these two combine together under enormous force of gravity, and when they combine together, they form helium. So two hydrogen atoms, when they combine together, they form helium. Okay, and then subsequently they release something called as a neutron. Okay, so when this helium is found, when this helium is made, so apart from these two, what comes out is an enormous amount of heat and light. So this explosion, this heat and light which comes up, it stops gravity from compressing it any further. But till a certain moment it has compressed things. So now what happens is that in order to prevent it from shrinking further, these nuclear reactions keep on occurring every single moment. Okay, this is something which keeps on occurring every single moment, so that it can completely stop any more shrinkage from gravity. Okay, and this will continue till the time you have hydrogen. Okay, so hydrogen is basically the input, helium is basically the output. Okay, so this reaction will go on till the time we have all the hydrogen in the star consumed. So when the nuclear reactions start and sustain themselves spontaneously, that is something which is known as main sequence star. Okay, just like all of you, after the age of 18, you are eligible to drive, you are eligible to vote, you are eligible to work for various things. Okay, so you are basically the ones who are right now in the stage who can self sustain their existence. You can work, you can earn money, you can subsequently sustain yourself without the support of anyone else. So this is something which is known as adult life. So for the stars, it is known as the main sequence star. Okay, main sequence is basically the adult life of the star. Okay, so it is the longest phase of that life. Here what is going to happen is that it is going to be the case that where you will find the entire you can say star glowing to its brightest form. So right now when you talk about the sun, it is a main sequence star. Okay. Now just like we have adolescence, teenage, okay, now that teenage is the time where you require some amount of support from your parents. You would require shelter, you would require food, you would require proper nutrition, guidance, okay, some amount of education. So that is something where the forces are not just yours but also of your parents. Now that is something which is known as the formative stage of your life. So that in the case of star is known as a protostar. Okay, so protostar is basically a star which has been born, and then subsequently it is going to graduate, or it is eventually going to grow into the main sequence star. So in the protostar phase, whatever heat and light is being generated, that is basically due to gravity. Okay, because of the action of gravity, because of the enormous amount of friction which is present in between the particles, the things start glowing. Okay, that is what happens. But eventually when the gravity is something which you can say collapses these things further, it shrinks these things further, nuclear reactions start. And from the moment onwards when the nuclear reactions start, the star actually enters into its main sequence, okay, or the adult life if we have to call it, right? So this is like our mother's womb, the nebula. So nebula is where a star is born. Why? Because of gravity, dark matter. Okay, so here all the things are going to start clumping together, eventually will come up as protostars. Okay, so now this protostar is basically going to determine what amount of mass are we able to accumulate. Just like when we were kids, when you were in school, so not all of your peers were of the same physique. Some of us were ultra lean, some of us were okay, some of us were a little chubby. Okay, so this basically means that what is the amount of mass that you have intrinsically. Okay, that differs for everyone. You might be knowing a few of your friends who basically are very lean, but they have very high weights. Okay, one of my friends was very lean, but the point is that he had weight more than me. And then I asked him, what is the secret? Then we understood another thing about human body. There is something called bone density. We asked this to a doctor. We were so, I mean, you can say stupids that we directly asked this to the doctor. He does not have anything. What exactly is his weight? And why is that weight? So he told us there is something called bone density. Bones can also be heavy. It's not just the physique that you have to see. Okay, we got it. Okay, so that way what happens is that the initial formative stage tells you what amount of mass you are going to accumulate. Okay, so from that moment onwards there are two separate, you can say, types of stars. Some of the stars are basically the ones which are like sun. Okay, sun is what we know, so we characterize it as sun-like stars. So sun-like stars have a mass which is similar to that of the sun, or till the time they are 3 times the mass of the sun. Okay, they are called sun-like stars. The other kind of stars are basically called giant stars. Okay, now they have greater than 8 to 10 times the mass of the sun. Okay, so there are two types of stars. So these are the lean one and the regular one. These are the chubby ones. Now it is okay that if you are chubby, you'll eat more food. That is why you won't share your tiffin with your chubby friends. You wouldn't get anything to eat, no, and they will not share their tiffin. But they have enormous capacity, right? That is the whole reason that I was very lean, but my friends still did not dare share their food with me because I had enormous capacity. Okay, so they would not do that with me. So what happens is that when you have a massive star, so you will have more amount of hunger as well. So what happens is that you will require more amount of fuel in order to keep yourself completely protected from gravitational collapse. You would require more amount of energy. So what happens is that when you basically have great amount of requirement of hydrogen as fuel, you basically are called a giant star. Okay, the other ones are basically sun-like stars. So let us first of all understand this, then I'll come to this. Okay, so when we talk about sun-like stars, so these are basically the stars which are, you can say, normal sized and normal mass stars. Okay, they're not too massive, they're not too light. So here basically what happens is that there is a balanced diet that you follow. Okay, you do not require excessively high amount of food, and at the same time you do not under eat as well. So what happens is that you only consume that amount of energy which you require. So that is why these stars have got longer lives, because you burn your hydrogen slowly and slowly. So the first thing I should be writing down is that a star will remain star or a main sequence star till the time it has hydrogen. Till that particular amount of time it will be called as a star. Okay. So when you talk about a sun-like star or a massive star, this is basically the stage when they are able to sustain their own nuclear reactions. Okay. It is this part which is the adolescent part, protostars. Okay. So when your stars are basically the ones which are able to sustain their nuclear reactions. So now what is going to happen in the sun-like stars, the consumption is going to be moderate. It is not going to be very heavy. So what happens is that they have longer lives. So what happens is that they will continuously keep on burning the hydrogen that they have, you can say, trapped inside them in the beginning. Okay. And when they continuously keep on burning them, eventually what happens is that all the hydrogen turns into helium. Okay. So once the hydrogen turns into helium, now what happens, there is no more energy that can be produced, okay, for you to you can say oppose gravity. So now what is going to happen, now the gravity is again going to compress you. So now when it is going to compress you, what happens is that because right now you do not have any fuel, you do not glow, and when you do not glow, the brightness is reduced. So then you turn a red giant. So red giant is the phase where you basically see that all the hydrogen has been consumed and now it is the turn of helium. It is the turn of helium to be compressed. So now the star is made out of helium. Okay. Now this helium is going to continuously compress. When the helium is going to continuously compress, again it will start a nuclear reaction. Okay. Now this nuclear reaction will now produce carbon. Two helium atoms produce carbon. Okay. So now the helium is going to get consumed and they are going to form carbon. After some time the carbon is going to be consumed, they are going to form oxygen, then they are going to form silicon and things like those. So this red giant phase actually has got many stages. Every time a kind of fuel gets exhausted, the next fuel is going to be consumed. Okay. So first of all the helium is going to be consumed. After the helium is consumed, again the gravity is going to take over. Next, carbon is going to be consumed. Okay. After carbon is going to be consumed, it will start reducing its size further, but it is all known as red giant. And eventually what happens is that they reach a particular point till they form iron. Okay. So iron is the last element which can be formed in this particular regard. Okay. After this what happens is that when you actually have to compress it even further, when you have to you can say fuse iron together, it requires enormous amount of energy, but that amount of energy is never generated inside the star. It is a very difficult process. So what happens is that when the gravitation is actually pushing these all things together, eventually the repulsion explodes the star, and when it explodes the star, it shatters into pieces, various kinds of pieces. Okay. And that again turns into you can say dust and gases. This again merges into the nebula. So this is the end of a sun-like star. Okay. You are ultimately left with something which is known as a white dwarf. So this white dwarf is nothing but neutrons which are together. All the other things are just thrown off. Is this understood? Any problems? So just remember that as soon as the fuel of a star goes out, gravitation is going to shrink it further. And in order to prevent this shrinkage, the next fuel, whatever is available, that is basically what element is there, it will start fusing till the point it reaches iron. Okay. And it is very difficult to fuse two atoms of iron together. It requires enormous amount of energy. So that is the end of a sun-like star, a white dwarf. But this will happen after a very, very long period of time, billions of years. Okay. Now comes the next part, massive stars. So now these massive stars are basically the one which have got greater mass than sun, 8 to 10 times the mass of our sun or even more. So now what happens, you are basically going to find that this is going to have a very, very high amount of consumption of hydrogen. Because the consumption of hydrogen is more, the lifespan is going to be shorter. You see here the red giant phase took billions of years. Okay. Now because these are massive stars, they don't find red giant, they become red supergiant. Okay, and that happens within a matter of million years. This is billion, this is million. And remember this because this has been a question in UPSC 2023. Okay, that a massive star, because of its high consumption of hydrogen, has a shorter main star or main sequence life. Okay, and after millions of years it turns into red supergiant. Again the process is same. It has exhausted all its hydrogen, it is now using its helium. Now what happens? Helium, carbon, all these elements are going to be found. Again you reach a point where there is iron. Okay, this is the last point that you can be seeing that happens with respect to the you can say contraction of the gravity. This is something which is formed. Now in order to fuse iron, it will require again enormous amount of energy. Even these red supergiants are not able to generate that amount of energy because of the collapse. So what happens is that when it starts collapsing, now after, because it has got greater amount of mass, so the force of gravity will be more. When the force of gravity is going to be more, the you can say the explosion is something which becomes even more enormous. Okay, and that is something which is known as a supernova. So when a supernova explodes, that basically means that a red supergiant which was continuously getting contracted suddenly rapidly expands like a spring. Okay, so when that happens, so it pushes a lot of material out of it, and it is because of this supernova that we have the formation of uranium. It is because of this supernova explosion that uranium naturally forms, because of the enormous blast energy that has been released. Okay, now all these uranium, whatever elements are going to be there, they again make a form, they form a part of the nebula again. But the point is that this is how naturally the elements are made. Okay, and after that, when this explosion has happened, now there are two pathways. Okay, for those stars which are 8 to 10 times the mass of sun, they are basically the ones which actually turn into a neutron star. Okay, so neutron star is basically the one which has got only neutrons inside it. This is the last thing. And things which are even more massive than that, more than 10 times the mass of the sun, they turn into a black hole. Okay, so black hole is the end of life. Black hole, neutron star, white dwarf, these three are the end of life of the stars. The only difference is the difference of mass. 8 to 10 times the mass, neutron star. More than 10 times the mass of the sun, black hole. Okay, less than 8 times the mass of the sun, white dwarf. Okay, so this is how the star actually you can say are going to have their life cycle. So it is a continuous struggle against gravity. Okay, so gravitational collapse is what drives a star to its end. It is the reason why it is born, it is the reason why it will end. So when you talk about a sun, the sun will end as a white dwarf after billions of years. Understood? And in this particular manner, because of this nuclear fusion that has happened so long in so many different stars, we have these elements captured in the planets, and that is how we have these minerals in our earth. There is no other way that these minerals have been found. They have been trapped in the nebula, and from that nebula, when the planets were getting formed, at that particular point all these elements were trapped in the earth. And that is how we have uranium, we have iron, we have carbon, we have sand, which is silica. Everything is a magic of this. Okay, understood? So this is basically the life cycle of a star. Any doubts? No doubts? So take a 5 minutes break and come back. So you will be finding some of the concepts here which are very heavily scientific. Okay, and after every such heavy scientific discussion, you will be getting your breaks. Don't worry about it. Okay, so go recharge yourself. don't get scared here. I just ask it out of curiosity. It's not like that I'm trying to test that you did your things right or wrong. It is just curiosity. Okay, chalo. Let's get ahead. Now we are going to talk about pole star. I told you about pole star the last class. Okay, now understand this. That, acha, before we do that, let me get you that video. I'll just show you the video I was talking about yesterday. I just told you about gravity and its impacts, how exactly we determine that how fast a thing has to go, if it is near or far. You're going to see that in a visual now. Okay, so just pay close attention. See, this video is basically about a white dwarf. Okay, so these are basically two white dwarfs. Now this is something which is an animation, so it is not something which is actually live captured somewhere. It is an animation which tells you that these are two white dwarfs which are about to collide together. So if they are two white dwarfs, they will have their own gravity. Okay, they're still very massive, so they have their gravity. Now see how exactly they start coming together and the way in which they are going to rotate around each other. Okay, see, can you see they are starting to accelerate a bit? That is starting to, now you can see it more clearly. As they come together, the rate of rotation is greater. Okay, and as you come together, it gets faster and faster and faster. Is anyone finding any kind of visual uh, issue with this? Okay, so this is basically how the things actually keep on turning. Okay, but what exactly happened? We understand that because of gravity, when the forces are very high, in order to remain at your original place, you will have to expend more energy. That is how you saw that the things started moving faster and faster and faster and they came close together. Why? Because when they are coming close together, the gravitation is acting even more. So in order to stay at your place, you will have to spin very, very fast. Okay, so that is what happened. These are some normal things which happen in the universe, and what you are seeing apart from that, these waves that you are seeing which are coming out, these are basically known as gravitational waves. Okay, that means that whenever one object is moving, a very massive object, when it is moving, it always carries some waves which are known as gravitational waves, and these gravitational waves are going to amplify when any such event happens. So now you can see the frequency of these waves are increasing more and more. Okay, this is what actually gets detected, and then we understand, okay, something massive has happened in the universe. So we have got various instruments called as LIGO. Okay, light interferometer gravitational observatory, LIGO. Okay, so these instruments actually detect these gravitational waves, and they then predict what kind of things might have happened in the universe, and then we try to capture this using the telescopes. Okay, got it? So this is the impact of gravity. Yeah, they do follow the same process, but the optimization of the fuel consumption is different. For you, drive a Range Rover, drive an Alto, which is going to be more fuel efficient? There is no point of having any other kind of explanation to that. Why is Alto more fuel efficient? Yeah, so if you talk about a Range Rover, you talk about a Scorpio, these are heavy vehicles, very heavy vehicles. Alto in that comparison is a light vehicle. It is a smaller vehicle. Range Rover is a longer vehicle. It has all-wheel drive. Alto has two-wheel drive. So these are the things which are going to require more fuel. So when they require more fuel, your fuel economy is going to be less. That's the reason. Both of them are working on the same internal combustion engine. Both of them are following the same Otto cycle, but the power requirement are different. Don't worry about it. It was for him. For you guys, you stick with the example that if you are like me, you will require more food. If you are like you will require less food. Okay, so if I am requiring more food, both of us are given same amount of food, it is very natural I am going to steal your food after some time, because I'll eat my food. Okay, then I'll not buy it or I'll not loan it from you, I'll steal it from you. Okay, in order for me to sustain, and you would feel like, okay, I need to rationalize. You will never know that I am stealing it. Okay, so it is basically the consumption of your fuel. Okay, now pole star. When we talk about pole star, yesterday I told you this is the most important aspect of navigation. When you do not have a map, you basically have the pole star to help you guide, detect the north, and this is of fundamental importance for any kind of navigation that you want to do, over land, on sea, even on air. Sometimes what happens is that when there are certain regions around the earth over which when the pilots fly, they lose their compass. Okay, their compass stops responding or giving the right direction, and subsequently what happens is that they find that they have actually flown off course. Okay, they were expected to reach somewhere, but they have not, because they deviated from their expected flight path. So in that situation, what they do, they actually look for this pole star so that they could understand in what direction was I supposed to go, and then they start moving towards that direction. Okay, so it is of very great importance when you are in the forest, lost. Okay, when you are in the sea, you are navigating, or you are in the air, it will be for everything. Now what happens is that when you talk about the pole star, it is called as the pole star because it always points towards the geographical north. Okay, now there are two types of north that are there on the earth. One is called geographical north, the other one is called magnetic north. So our earth also in itself acts as a giant magnet. Okay, so any magnet which is there always has two poles, that is called as the north pole and the south pole. Okay, similarly the earth also has something called as geographic north and geographic south. Now how do we characterize that? We have an axis, we have an imaginary axis over which we imagine that the earth is rotating about, like a top. Okay, like a top, it is actually rotating about this particular axis. So the point at which this particular axis crosses the northward direction, that is called as the north pole, geographic north, and the point where the axis crosses the southernmost part, that is called as the south pole. Understood? So now with respect to the pole star, this pole star basically always aligns itself in the direction of this north. So that is why when you are looking at the pole star, you can be confirmed that you are looking towards north. Now how does this magic happen? When the earth is rotating, I told you yesterday that there are things which are going to move in the sky. So why does the pole star does not change its position? Okay, so what happens is that when you talk about the pole star is basically located far away from the earth, but it is located very close to this axis when it is produced infinitely. Produce basically means that this is the axis that we know on which we have the earth spinning. But if we are trying to imaginatively, if we extend this axis in the direction of the sky, okay, so this pole star is located very close to this axis. So in that particular regard, what happens is that when the earth is rotating, when the earth rotates, so to an observer on the earth, it seems like everything is rotating. Okay, the farther an object from the axis, the greater would be the distance it travels. For example, when you talk about the moon, okay, you talk about the sun, it is basically the rotation of the earth which causes the sun to rise from the east and set in the west. You see a very great amount of you can say distance between the two sides, and it feels like an arc, right? A similar thing happens with all the celestial objects. You see this with respect to the moon as well, right? So what happens is that all the objects, the farther the distance they are from the axis of rotation of the earth, the greater would be the displacement that you see in their position in the sky. Okay, now what happens is that this particular pole star is very closely aligned. It is very closely aligned to the axis of rotation, something like this. If this is the axis of rotation and you are looking from the top, so it is very closely aligned. So when the earth is rotating, it takes a very small circle with the earth. So what happens, because it is taking a very small circle or towards the earth, we do not find that distance that it has displaced from one point to the other, and that is why we say that it always points towards the north. Okay, now the point being that when you talk about it, so this is basically right now the position of the star. So this star is found somewhere here. So when the earth is rotating, it takes a very, very small circle, and that is why it always points in the same direction. Now, when the axis of earth gets tilted, when the axis of earth will get tilted, the pole star is going to change. So pole star is basically any star which is very closely aligned to the axis of rotation of the earth, and as a result we find that it always points towards the geographic north. So what do we get from here? That pole star is not fixed. It depends upon the axis of rotation. Today it is Polaris. The star is actually known as Polaris, which is very closely aligned to the axis of rotation, and hence it is known as the pole star. Okay. In the future we'll see that it will be Vega. The next star which will become the pole star will be Vega. Why? Because in about 26,000 years, the axis of rotation itself rotates a full circle. So when it is rotating a full circle, so every time it is changing a direction, there will be a new star which will become the pole star. Do you understand this? Any doubts? So this is basically the concept of a pole star. Understood? Should we go ahead? Now, Cephids. Okay, now Cephids are basically the stars which are actually known as timekeepers of the galaxy. Okay, so Cephids are basically those stars which have a very constant time of brightening and then dimming. Okay, just like you have as decorative bulbs, we have tunic bulbs. They have a constant time period when they brighten and when they get dim. Yeah, for that matter, they could actually be glowing green for some time, then red for some time, then yellow for some time. There is a constant time period. In a similar manner, we have Cephids in the sky. They are basically having the speciality that they brighten and dim periodically. You can calculate the time, that after every 2 seconds, just like a pendulum. Okay, so a pendulum is something like that. You can actually predict that after 2 seconds it will be here, after 2 seconds it will be there. In a similar manner, we do it with the Cephids as well. Okay, so the Cephids basically are the one which say that the longer the time taken for them to change from fully glowing to complete dimness, this time period is proportional to the brightness of that particular Cephid. Okay, so the greater the time taken by it to change from dim to bright or bright to dim, the greater will be its brightness. That is why what happens is that based upon the duration or the time taken by these stars to glow or to get dim, we actually estimate the distance of various galaxies from the earth. Why? Because we basically are constantly observing certain of these Cephids, and we try to take the time. What is the time taken by the light that is coming from the Cephid towards us, okay, to dim or to brighten, and based upon that we try to estimate how far a particular star or how far a particular galaxy is from the earth. Okay, so these Cephids are found very, very commonly in the universe. It is only a matter of identification, and many scientists observe different but specific Cephids. The whole reason being that the better or the more amount of observations you have of the Cephids, the better would be the estimation for calculation of the distance. So that is why whenever Cephids are discovered, they are assigned to various teams across the world for their observation. Okay, so that is why this is something which actually is very, very useful for estimating the distance of the star from the earth. Okay, so this is basically how you see the Cephids. So in this particular figure, if you are seeing, there are 4 different images of a Cephid. Okay, they have been taken on December 17, 2010, December 21, 2010, December 30, 2010, and January 26, 2011. You can see the brightness change. Okay, so that has happened over a period of month, about a month. So this time is basically the time taken by the light to actually reach the telescopes through which we were observing this, and subsequently from this particular thing, we are going to estimate what is the distance of this particular star from Earth. Why? Because we have two things. We know the speed of light. Okay, speed of light remains constant in the universe. We know that speed. We have got the time. We have a formula called speed is equals to distance upon time. When you have the speed, you have the time, you find the distance. Okay, so speed of light is constant in the universe. Whenever the light actually travels to the universe, it is constant. Okay, so we have this, we know this, experimentally determined. We calculate this by taking these photographs. Okay, and then subsequently multiplying these two, we find the distance. So if you are going to attend my CSAT classes, you will find ample questions, not on Cepheids, but yes, on speed, time and distance, where you will be using the same concept. Okay, now this same thing is also used. Do you know radars? You have heard the term radars. Okay, for tracking anything that is moving. That could be an airplane, that could be a missile, that could be a submarine, that could be a ship. In order to track anything that is moving, we basically track it using radars. Okay, so these radars also work on a similar fashion. They send out waves which are radio waves. Now these radio waves hit an object and they strike back, they reflect back, and we have a computer which takes the time, that what is the time taken for a particular radiation to come back, and hence we determine the distance of that object from us. That is how we track anything. Okay, it is also used for aerial surveys. Okay, just like you basically see that when we have to, let us say, lay down a railway line in a particular region of India, which is right now not having any railway line. So what will be the optimal route for laying down that railway line? That is determined by a radar or LiDAR survey. Okay, that uses the very same thing. It will track the entire, you can say, surface of the earth over which this particular thing would be easiest. The same way we also do it for studying the landforms within the ocean. So that time we will be studying how exactly World War II contributed towards it. So is this clear with everyone? Okay. Now the next thing we have is something we know as a very famous bike, pulsar. Okay. Now pulsar actually is another short form for pulsating star. Okay, so a pulsar is basically a pulsating star or a neutron star which gives out pulses of magnetism. Okay, so what happens is that it is a very rapidly rotating object in the universe. So whenever we basically are observing a pulsar, okay, so there are certain time periods when we receive enormous amount of energy. Okay, and there are certain periods we do not receive any kind of energy. Okay, so that is why it is known as pulsating. When it is pulsating, it will give a high amount of energy output, and when it is dimming, it will give no output. And this continuously goes on. It's a very rapidly rotating body. It rotates just in the same way that you saw in the video. Okay, so here basically what happens is that this is basically found towards the end of the life of a star. So it's a neutron star. So this is basically going to happen when a massive star runs out of its fuel completely. So at that particular moment of time, what happens is that it basically gives out various radiations while it is rapidly rotating. And whenever that radiation is received on the surface of the earth, it basically gives us a high output signal. Okay, and when it is not received, the output is low. Okay, so that is basically how you see a pulsar. Okay, so when you talk about pulsar, these are basically the ones which have very strong magnetic fields. Okay, so why do they have magnetic fields? Because they are only left with only charged particles with them. They don't have anything else. They don't have any kind of atoms. They have nothing else. So now, because I told you that beyond iron you cannot have any other things forming. Iron is something which is magnetic. Okay, so you can very well expect that when you are actually in a pulsar, you will be having iron, and when that iron is going to collapse, it is going to break down, it will produce this magnetism. Okay, so that is something which you receive as energy on the surface of the earth. So we have various kinds of instruments to detect them. Okay, and that is how you have a pulsar. Now see, this was basically a question that was asked in 2023. Is the question visible? Should I zoom in? Yes, or I'll just have some central. Okay, very sorry. Yeah, So read this particular statement and try answering the question. This kind of question was the one which was the scariest for the aspirants in 2023, because after a gap of 20 years, a question like this was asked. This is the newest pattern of question, assertion reasoning. Okay, it is not the case that UPSC has never asked this question. So what happens is that here you basically are given two statements. Okay, and first of all you have to evaluate their factual correctness. Are they both factually correct or not? The second thing, after that you have to evaluate if the second statement correctly explains the phenomenon given in the first statement. Okay, you have to analyze only these two aspects. First of all, factual correctness. If one of them is factually incorrect, you will have an option. Okay, if both of them are factually correct, then you will have to understand, is the second statement the reason for first statement? So just read this question and let me know what is your answer. You can tell me your answer A, B, C, D. D. How many with D? Oh, yeah, 3 to 5. We have 5 with D. Ma'am, you are with C? How many with C? Only one. Okay. Rest of you? The lady diagonal. Okay. And you, madam? I really hope you are not going with the majority here. You have a solid reason for that. Okay. See, it's okay. Even if it is wrong, it's okay. Make your mistakes here, not in the UPSC attempt. So it's okay. Try. No issues. At the most, what will happen? It may go wrong. When it goes wrong, your mind is then activated. Don't worry about it. Tell me. Even if you're not, so guess it. D. Going with the majority. So then why so much of thought when you have written it down? Okay. See, whatever I am going to speak, that is not the only way the questions are going to be asked. Okay. That's the first learning that we should be having. Yes, there will be some variation in the way they are going to ask the question. So instead of sun-like and massive stars, they have given giant and dwarf stars. It does not make a difference. Okay. Now, what exactly is the question? The first statement is giant stars live much longer than dwarf stars. So basically it is a comparison between massive stars and sun-like stars. Sun-like stars are the dwarf stars. If you want to write it down, I will write it down here. So the dwarf stars are sun-like stars. The giant stars are massive stars. So it is given giant stars live much longer than dwarf stars. The second one, compared to the dwarf stars, giant stars have a greater rate of nuclear reaction. So first statement goes wrong. Why? Because if you are massive, you will require more fuel. If you are requiring more fuel, you will have more nuclear reactions. That is why it is wrong. But the second one is correct. That as compared to the dwarf stars, there will be a greater consumption of fuel and hence greater rate of nuclear reactions. Okay, so the second one is correct. The first one is wrong. Okay, so now you just have to find out the option which matches your preference. Statement 1 is incorrect, but statement 2 is correct. Madam, why did you say option C? You were confused with the, okay. What exactly was your confusion? No, I mean, what exactly, how did you process it? Okay. So you missed that point when I said that when you are massive, you will live less because you are eating your food more quickly. That does not apply to me, but stars. Okay. So that's the thing. Understood? So see, is this question very difficult to solve? But in 2023 was the first year that I literally saw people coming out of their examination hall crying. Okay. Deathly silence. Why? Panic. This question is not something which is very tough. Very clear cut statements. Nothing that a particular person who has read it properly will not be able to solve. But because you are not solving such questions or you have a different approach to solve this examination, you panic. This is a year which got the historically lowest cutoff of UPSC, 75 for general. Lowest ever cutoff. Usually the cutoff for general category varies between 90 to 87 to 97. 75 was the cutoff. Why? People were not able to solve it. That's the thing. Okay. Okay. Now this one. Again UPSC 2023. What happened? Solve it. You can expect such questions in UPSC. Match the following is usually coming like this. None. Anyone else with none? Two with none. Okay. Only one. Anyone else with only one? Three of you? You also want to go for only one? Yes? Now again we are left with the lady diagonal. This time a different one. Guess it. If you do not know the answer, guess it. Anyone? And you? See, I do understand I am fat, but please don't make me work back and forth like that. Please tell me. Oh, so you have this, these are the options, no? How many of you feel are correctly matched? You just have to count the pairs which are correctly matched. So the term and its definition, if they are correctly matched, so you count them as one. So is it like that? How many pairs according to you are correctly matched? One. So that's the answer. Okay. For those who said only one, which one of the above is correct? Pulsars. This one is correct. So why did you guys get it none? Why wrong? Yeah, they are interchanged. Good. But what about the third one? I said pulsars are neutron stars. Go back to the class. Neutron stars. I said they are neutron stars. After the end of your life when you are having iron. See, iron is something that will form in both the cases. But with respect to pulsars or neutron stars, you have much more amount of mass accumulated. That's why you have pulsars and cepheids and everything. You don't have such things there. This one is correct. And you are correct in this also, that Cepheids the definition is this and the nebula the definition is this. Correct. So they are incorrectly matched. But the last one is correct. What was your justification? No, no. It is for neutron stars. Neutron stars are never dwarf. They are white dwarf. Go back to the figure that I told you. That smaller stars, sun-like stars, end as white dwarf. But pulsar is a neutron star. Neutron star is the end of life for massive stars. Okay? Both of them 2023 question. Now, when you are reading the question, you have to read the question right. Okay? Just like ma'am had some confusion in understanding which answer to be given, and that's a very normal thing. So that is why you should understand what exactly the question is asking. This question is basically asking that there are certain pairs given. Okay, on one side the terms are given and on the other side their definitions are given. Now it has been asked to you that you have to consider these pairs, that is the term and its definition, and you have to check how many of them have been correctly matched, meaning the pair and its corresponding definition are correct. So you could understand that with respect to Cepheids, these are basically stars which periodically dim and bright. But in front of Cepheids, it has been written giant clouds of dust and gas in space. So that is wrong. Cepheids do not have this definition. With respect to nebulae, it is basically the giant clouds of dust and gas. But the definition given in front of the nebulae is stars which brighten and dim periodically. Again, this is wrong. The third one, pulsars and the definition. Now, when you read the definition, it is something which is corresponding to what pulsars are. So this pair is correct. Okay. So only one out of these pair is correct. That is how you answer these questions. Okay. So see, what happened was that you knew the concept, but you did not know how to answer this question. This is also one of the ways in which you will be losing out some marks. So that is why unless you try how to answer this question, you will not be understanding what exactly the question is asking. Now the next thing that I want you to read very carefully is this statement. Sometimes instead of correct, they will ask incorrectly matched. So if the question was incorrectly matched, there are two such options. There are two pairs which are incorrectly matched, but correctly matched only one. Okay? Got it? Okay. Now this is basically UPSC 2012. Read the question. Is the question visible to everyone? Now this is where a CSAT question comes in first paper. D. How many with D? 2. You also with D? I'll get it 2 here. That's okay. It's okay. I'll have some curling exercises for me. Yes. Don't worry. See, in such questions, if you get confused, draw. Use the rough space. You are given two sheets of rough space in the question paper. Draw, and then understand what should be the right one. If you're not able to visualize it. Draw. No issues. Draw. Yes, my central elements. D. 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 And you? Finally, you guys spared me. You gave D, no? So you see, this is another rule of my class. Once you opt an option, you cannot opt it out. Why? Because UPSC does not give you that chance. Once you have marked it, you have marked it. So think before you answer. Okay. Now let's talk about the question. A person stood alone in a desert on a dark night and wanted to reach his village, which was situated 5 kilometers east of the point where he was. Okay. He had no instruments to find the direction, but he located the pole star. So pretty smart fellow that he located the pole star. Okay. The most convenient way to now reach his village is to walk in the. So you have to determine the direction in which the person has to walk. And the options are direction facing the pole star. So direction facing, if you are facing the pole star, you are facing towards which direction? North. So let us decode it from here, that it will be the north direction. So yes, it is not going to be the right one. Direction opposite to the pole star. So that would be south. So he has to go to the east. This cannot work out. Okay. Direction keeping the pole star to his left. Okay. So if the pole, I am a left-handed person. Okay. If the pole star, if this is the pole star, if that clock is the pole star, this is the north, right? So this direction would be east. So if I move in this particular direction, I have the pole star in the left side. And what was the question? You have to go towards the east, right? So if you have to go towards the east, this is the direction which will be showing east. Now direction keeping the pole star to his right. This is my right hand. Okay. If I walk in that direction would be west. So where exactly did we have to go? We have to go towards the east from the point where you are standing. So if I am standing in this direction, I have to go that way. So how exactly I will be moving? Keeping the pole star to my left. So this is another learning for you, that majority is always not, it is not always right. Okay. Only one person voted for C and she was right. So that is why in such questions, now this question is something that is usually seen in CSAT paper, second paper. But just because of the concept of pole star, this was asked in the first paper. Okay. So you can now expect that UPSC not only asks you question of first paper in the second paper, it also asks the questions of second paper in the first paper as well. Just like in 2025, you had questions on calculating fiscal deficit. Literally, you were given values and you were to find out the fiscal deficit, you were to find out the primary deficit. Okay, which you expect to do in the second paper in mathematics. That was there in the first paper. So now the UPSC does not have any bounds for that. It will not be doing this, it will be doing that, it will not be asking this, it will be asking that. Understood? So this is basically the question that you have at hand. Any doubts in the question? Are you understanding how to approach a UPSC question? Okay. So we'll start this tomorrow, the solar system. If you want to read it, you may. If you don't want to, don't read it. I'll make it read it to you. Okay. So see you tomorrow. If you have any doubt, stay back, or you are done for the day. Thank you.